Hi everyone, welcome to day 7 of my cloud series. So today we going to learn computer networks, and in that the topics we are going to learn is first introduction to computer networks, second LAN, MAN, PAN, CAN, and third TCP and IP protocol suites, fourth physical layer in computer networks, fifth topologies in computer networks, and sixth mesh star hub bus like that topologies we are going to learn in detail, and seventh manchester encoding and differential manchester, and eight various device in computer networks, ninth types of cables in computer networks, 10th hub in computer networks, 11th bridge in computer networks, 12th switch hub and bridge. We are going to learn this in details also, so through diagrams and all and examples, and 14 collision and domain collision like that. So we are going to learn this topics today. Basically we have completed operating system, so now we are going to learn computer networks. And if you see, computer networks is so easy, and you can like uh, learn this topics, and you can analyze or you can see in your day-to-day to life, like how you get to know how your wi-fi routing works. You get to know that. So it is a interesting computer network is so interesting, so you have to just learn this. Okay, so I'm going to my notes. So if you see, what is first introduction to computer networks. So this is a sender and this is a receiver. So you are sending some message to sender, sending some message to receiver. So through wide or wireless. So this connection is look up by computer networks through protocols, like message is sending properly or not, and with encryption and security or not. This all this thing handled by computer networks. And if you see the proper communication, if we follow protocols, and if you see process inter process communication, it is handled by operating system. You know the pro- process communication, it is handled by OS through kernel. Okay, so you understand. So what computer basically does, it feels like a machine 1 and machine 2. If like this machine is from India, and this machine 2 is from located in USA. So what computer networks will do, it give the all facilities and everything. So machine M1 and M2 does not know that they are same in, get to know that they are same environment like that. Okay, so the functionality of computer network is mandatory and optional. So mandatory is like you have to error control, second flow control, like buffer is not going to fully message that. You have to be like control that somehow amount of message will pass and all. So flow control, error control, like if a message is M1 is message is passing to sender is sending message to receiver, that message is passing that message is completely uh, receive or not, with error free or not. So this is the mandatory, and second flow control, and the multiplexing and demultiplexing also have. So there is lot of mandatory, and optional is encryption. You have to do encryption, like like if you don't want to encryption like HTTP, and if you have to send your data through so encryption, so there is a HTTPS like that. So it is like that. And checkpoints like 30 MB after failure, is there is failures or not like that. So it's an optional thing. So this is the functionality of computer networks. And you can see now OSI model. What is OSI model? First, like if you go see, first is physical layer, after that data link layer, after that network layer, after that for transport layer, after that session layer, after that presentation layer, after that application layer. So what we are going to do, we are going to learn this in deep. Every layer we are going to learn deep. Okay, so firstly I will going to explain PAN, LAN, CAN. Okay, so PAN, after that LAN, after that CAN, after that MAN, after that WAN. So what is this? Man is like a personal network, personal area network. So it's low range, low range. That's why it's personal area networks. So what will it in that Bluetooth or India, Indra and Zigbee, and it's a high speed because it's a low range. That's why it's a high speed. And if you see area within a room, that's why it's high. And ownership in a private. And maintenance is very low because it low range. That's why it's less in like on very space, like e- easy to maintain that. And error rate and cost is very low because range is low. That's why if you go line after you see this pan, after there is a LAN. So if you see that LAN, local area network, so what is that? Ethernet or your Wi-Fi. So that is a LAN. Okay, so the range of up to 2 kilometer, and speed is very high, and area within an office or building. Okay, ownership, if you see in Indian Railways, there are Wi-Fi now. So the range you can through, if you go other side of platform, or the like corner of the platform, then also you can access the Wi-Fi, because the range of that LAN is 2 kilometer. That's why. Okay, so it's very high speeds, and ownership is private. Maintenance easy because now it's only 2 kilometer. That's why its ownership is low. And if you see uh, like this, error is also low, error and error rate and all. Okay, now after that, pan, LAN, can is there. Okay, like it is increasing the range. It is basically increasing the range. That's why this LAN, man, pan, can are there. Okay, campus area network, if you see in your campus, you will see there is a Ethernet they all use. So it's up to 1 to 5 kilometers. Speed is high within a university or corporate office also. Okay, private, moderate and moderate, like ownership, like maintenance, like it's moderate, not easy. Sometimes like expensive and all. So that's why also. And error also moderate. That's why. Okay, and man, metropolitan area network, if you see FDDI, CDDI, ATM, it's like a metropolitan network. Okay, range is up to 5 to 15 kilometer. That's why it is speed is average. And within the city like Mumbai, if you are in a city, like I am living in Aurangabad, so I can communicate with another city peoples like that. So it's like a man like that. Okay, and it is private also and public also. And maintenance is difficult because its range is so long. That's why it's difficult. And error also high. Okay, and the last is WAN, wide area network. So it is like man, it's like changing your exchanging your data or transmitting your data through in different cities like that. And if WAN is like you are transmitting or accessing your data or transmitting your data to other country like that. So WAN is like that, wide area network. So it's least line, dial up above 50 kilometer. It's about always above 50 kilometer. Low, what is low, like speed is low. And within countries, private or public, very difficult because very difficult to maintain. And very high error chances will occur. That's why. Now we are going to learn TCP and IP protocol suites. So if you see this OSI model, this OSI model only in a theory, it's never been in a implementation. But if you see TCP and IP protocol, these are have implemented. That's why it is made. So if you see TCP and IP protocol or internet protocol, so if it is developed by a parent. Okay, and the support client to client and server. And peer to peer. What is peer to peer? Like you can send one like everybody can share their transmit like that. Okay, so if you see application and presentation and session layer, in layer 4, it's become application layer. Okay, they are going to do same work. Like it's like a they are going to access to process. Okay, and it is a transport layer and internet layer. It's host to host, and it is destination to host. And if you see network layer, access layer, and network access layer, this is come in this full. Okay, this is the four layers. One, two, three, four. Okay, this is the four layer. And if you we can talk about fifth layer also. There is application layer. In this application layer, this application layer, presentation layer, and session layer come in this application layer. Okay, transport layer is there, and network layer is there, and data link layer, and physical. Okay, so it is like that. So we will going to discuss in detail that what is physical layer, what is data link layer, what is network layer, transport layer, session layer, presentation layer, and application layer. Okay, so now we are going to learn physical layer and its functionality. So if you see in what is physical layer, nothing but cables and connectors. Okay, and if you see physical topology hardware, in physical layer there will always be hardware. Okay, like repeaters, hubs, like that, transmission mode, and multiplexing, encoding. Like if you what like from data link layer, it's converted in binary. So what physical layer do, this binary physical layer convert this binary data into signals, and from sender side. And what will happen in receiver side, this signal will convert into binary. So it's like that. So physical layer do this, like these things. Okay, now we're going to learn topologies like device key arrangement. Okay, so there will be if you see, this is a mesh like B, C, D, and every device is connected to each other. So number of cables, we can, there is a formula like n into n minus divided by 2. So it's number of nodes minus number. So if you if somebody asks how can you like give me number of cables, how many you have to take out the number of cable in mesh, so you have to just to use this formula, and you can give that this is the number of cable we have to required when if you use mesh topology, like that. Okay, so if you see, it's a number of ports. If you can see a number of ports also, n minus 1 and into n, so you will get number of ports. Okay, so reliability is in mesh is highest. Why? Because if you see reliability means like if if A and B D are communicate transmitting any data, and this transmission is happening and there is something error, then what will happen, A transmit their data through B, and B transmit data to D. So in this what will happen, this reliability will highest. Okay, cost will be high because we have to use many cables, if you see like that. Okay, and security is, yes, it's provide security high, because if you see A and D are communicating each other. So A like B and C doesn't know what they are transmitting and all. So its security also is good, and point to point, like they are point to point connecting, like that. Okay, dedicated to communication. Okay, and we are going to learn star and hub. So what will star hub? It's like that multi-port. So A will be connect through this, like that. But what will happen, it's like a very less reliability. Why? If this hub will error error happen or something happen, so this they will not communicate each other, like that. You can see through these notes, you will understand better. In cost, it's less cost compared to mesh, because we are using less cables, that's why also. Okay, in security, it provides security but less as compared to star. Okay, point to point, it supports point to point communication also. Okay, now what is we are going to learn, it's bus topology. Well, what is bus topology? We are going to use one backbone cable, and there is so many connected devices, through that they will communicate or transmit their data. So there is a terminated or repeater. A repeater, it's like a regenerate your signals, it's a repeater, like that. Like this cable has only 100-meter range of sending signals. After that, the signals will lose their strain. So what repeater will do, it strain that regenerate that signals, or strain that signal. It's like that. Or terminator, like the terminate that. Okay, so if you call this is called a backbone cable. Okay, this thick ether wire, bandwidth high. Okay, this is a tap, and this is a drop lines. Okay, if you can see number of cables and all, reliability is less, because if this backbone is damaged or anything happen, then this all devices can't communicate. Security less, because if the it's like a bro, 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 broadcasting to all of us like that, so it's not good. And is in less security. It is cheap as compared to mesh. Multi-point is there. Ring, what will happen, it's nothing but bus, but in a like this, okay. And there is a token ring. And it in all in ring also there is a less reliability, security is less, cost is cheap, but this is also like that. What is Manchester and the differentiate? So if you see, this is the if you want to take out the signals and all, so you can use if one like this and zero like this. So you can, if there is a binary, you can just like this, you can identify the signals like that, nothing but like that, okay. You can see and you can learn that, okay. So various device in computer networks, there are cables first, repeaters, hubs. So this is are the pure hardware, nothing in there is no software, okay. And fourth, bridge, fifth, switch, and sixth, routers. In this, hardware is also there and software is also there. And gateway, IDS, firewalls, and modem, they are like softwares. And this is the used to gateway and IDS used for security, okay. So what we're going to learn is cables. So there are three types of cables: unshielded twisted pair cables, and coaxial cable, and fiber optics. So if you see, this is what is 10 base T. So nothing but 100 meter, 100 100 meter like that. So it's a 100 meter. 100 base means 100 meter base. So in that it will transmit their data to 100. After that it will be weak. So this is called the authentication, okay. And it's like a it's passing electric signals, it passing light signals like that, kilometer, and it's a range in these cables, okay. What is repeaters? In it is a physical device we have discussed. So repeaters I have explained you. This some this cable or this bandwidth has only 100 meter, and after that that signal will be lost their strength. So what repeater will do, regenerate that signal strength, and no and pass that signal forward like that. So it's like that. Amplifier, what amplifier do, it will 2x that signals. So there is a difference between amplifier and repeater. What repeater will do, it's regenerate the signal strength. And what amplifier does, it like 2x or 3x will be strengthening that signals. So this is the difference between repeaters and amplifier, okay. You can understand by three this example also, okay. So two device port, yes, for in this it's forwarding, because like if you see forwarding. And there is no filter in repeaters. Like what filters, like if a have are going to like that, so you can understand. Collision is like happening in this domain, in this repeater, okay. Now hub is a multi-port repeater. Forwarding, hub is a multi-port repeater. If you see, it's a multi-port, there is a port multi-port, and you can do that. So it's also forwarding a high traffic, it's, and no filtering is also there in a hub. And collision is also there in collision domain is also in there hub, okay. What is bridge? Physical and data link layer, it's okay. So this is hardware and this is software plus, okay. So connect to two different lines, it connect two different lines. Some something like it's different line, and this is different line. So what we'll do, bridge store a table where there is a statical and non-dynamical, and in through this what will it store MAC address, okay. So if you say, there is will be forwarding and filtering also, because through that table they will identify it's there or not like that. So through MAC address, okay. There is no collision domain, because why, it's because of table because in table there is store of MAC address. That's why it's filtering that if they want to go there or not, like that. And bridge data unit protocol also there. Okay, now we are going to discuss switch is a layer 2 data link layer device. Okay, multi-port bridge, it's a multi-port bridge and fully duplex links. Traffic in minimal, traffic is minimal, and collision domain is 0. Okay, if you see this diagram you will understand. And router, physical data link and network data link also data link layer also there, and network layer network layer data network layer internet also there. Okay, like layer. Okay, network layer also there. So this is your internet, and there is a forwarding also there, filtering also there, routing. It's router nothing but I have explained you, they use IP address also. So through IP address they will have, so that this MAC address connected to so many people, so many channels and so many networks. So this A have a that host address and host destination, so where he has to destination. Okay, so like it's HA and HB, so it's going to router B and C. And so router are connected to so many networks, it see. Okay, there is a routing table. In routing table all the data has saved, that router where it has connected to this network. It see, okay, this network has there, so it will pass your data to it will forward you there. So there is for filtering also there, forwarding also there, routing table, floating also there, and collision is not going to there, going collision is not there. Okay, collision domain versus broadcast domains. If you will see this device name, repeater, hub, bridge, so there is no collision. Like in repeater and hub there is no collision domain, but and no collision in broadcast domain also not there. Okay, and if you see bridge, switch, router, reduce, no change, no change. I hope I have explained you very well. So we are going to learn tomorrow with new topics. So I hope I have explained very well. So this is the interesting, computer network is so interesting. If you learn and you understand and apply day to day life, you will understand how routing is working, how DNS working, how this working. You then you will going to interest in this subject. So it's so theoretical, but if you apply in, and if you think in every device, so you will understand, okay, this thing, this device work this channel work this. So you will got you more curious and you be more interested in this subject. So it's good, you will better understand. I hope I explain very well. And till that time we'll going so what we are going to do tomorrow, going to learn new topics. So till that time, take care. Okay, bye.